Hello students, welcome back to today's class on probability, and in today's class we're going to discuss some applications based on what we have discussed in the previous classes, right? My name is Avinash and I'm a graduate from IIT Kharagpur. Let's start today's session. So what's the first question that we are going to discuss here? A die is thrown 300 times and odd numbers are obtained 153 times, and the probability of getting an even number is, right? So once again, let's try to see that. As also we have discussed the same type of questions, right? A die is thrown 300 times, a very simple question. So please try that for 1 minute, and then we'll discuss on how to solve these questions. Last 30 seconds, so please try to solve that properly. It's a very simple 300 times. If you're getting out of 300, if you're getting 150 times odd numbers, you know how to get an even number. How many times even number will be repeating? Right, so let's try to solve this one. So out of 300 times, we have odd numbers obtained 153 times. The total the cases are 300. Out of that, odd numbers are 153. 300 minus 153. 300 minus 153. What is the answer then? So 300. So odd numbers are 153. I'm sorry. So odd numbers are given 153. So now tell me how many even numbers are repeated. How many times we are getting even numbers? So 300 minus 153, it should be, if I'm not wrong, 147, right? So 147 times even number is being repeated. Now, then the probability of getting an even number. So probability, whenever discussing, I told you, it is a total number of favorable cases by the total number of events, total number of cases, right? Number of favorable cases by total number of cases. So favorable is, if we need to get even number, which is 147 by the total number of cases, so that is 300. So 147 by 300. So if you can try to solve that, 3 ones, we can write this as 147 by 3 into 100. Okay, so 3 ones, 3, how many times is 4 is 12, and 3 nines are 27. So 49 by 100, so that will give you 0.49. 49 by 100, so that will give you 0.49 is the probability of getting 0.49 is the probability of getting an even number when you throw a dice, right? A die is thrown 300 times, and that will get the probability as 0.49, right? So the next question we are having, the probability of an impossible event. It's a very simple. Just in 10 seconds you can tell me the answer. I'll give you 20 seconds to tell me the answer. 20 seconds. Impossible, the name itself says that that event can never occur, right? The probability of an impossible event, the event can never occur. Sun rises in the west. Sun rises in the west is an impossible event. We can say that it is not correct, right? The probability of an impossible event is more than 1, less than 1, 1 and 0. So it's enough. You can say impossible, so that event will never occur, and we can say the answer for that will be 0. Right? So moving ahead with the next question, if a probability of E is some P of events, probability of event, some event E. Some probability of event is 0.44, then probability of not E. What do you mean by not E? That means the E should not occur. The event E should not happen. But it was already given the probability of E, the occurrence of event E is given as 0.44. So we need to find the probability of non-occurrence of the event E. So please try to think about that. Right, last 15 seconds. Right, the last 5 seconds, let's try to solve this one. So whenever I said occurrence and not occurrence, the total probability should be 1. Always try to remember the occurrence of the event, probability of E and probability of not E. Okay, so these two will add up to give you 1. The probability of event E and the probability of event not E will add up to give you 1. So it is a 0.44. So and let's say some x is equal to 1. So x is equal to 1 minus 0.44. X is equal to 1 minus 0.44. So it will be 0.56 if I'm not wrong. Careful, check that. Right, that is 0.56. Okay, that is a probability of non-occurrence of the E or probability of not E. The total sum is always equal to 1. Okay, so moving forward, 2 dice are tossed. The probability of getting 2 5s are 2 dice are tossed. As also we discussed, when 2 dice are tossed, how many cases are we get? And in that cases, the probability of getting 2 5s is. So please try to do it quickly. Last 20 seconds. Last 10 seconds. Right. So let's try to see the answer. 2 dice are tossed. The probability of getting 2 5s. As we discussed, a total of 36 possibilities are there when we toss two dice, right? So the die 1 will have the options 1 2 3 4 5 6, and the die 2 will have the same options 1 2 3 4 5 6. Total 6 plus 6, it's not 12. The total occurrences are, in the first dice if you get 1, the second dice will give you 1. So that is one one possible outcome, or 1 comma 2, 1 comma 3, 1 comma 4, 1 comma 5 and 1 comma 6. So let's try to write all this. 2 1, 2 2, 2 3, 2 4, 2 5 and 2 6. 3 1, 3 2, 3 3, 3 4, 3 5 and 3 6. Next 4 1, 4 2, 4 3, 4 4, 4 5 and 4 6. 5 1, 5 2, 5 3, 5 4, 5 5 and 5 6, and then we are left with 6 6 1, 6 2, 6 3, 6 4, 6 5 and 6 6. So these are the total possible 36 outcomes when we are throwing a die 2 times. Okay, 2 dice are thrown. 1 2 3 4 5 6, 6 plus 6, 6 into 6, 36. Now the probability of getting 2 5s, in how many cases we get 2 5s? That's only one time in the total 36 cases, that is 1 by 36. Okay, so that stands for 1 by 36. Option 3 is the correct answer. Right, a straightforward simple question. Let's move forward for the next question. In a football match, a player hits 8 goals out of 60 balls. Out of 68 goals, find the probability that the player did not hit the goal. Find the probability that the player did not hit the goal. So please quickly do that. Last 30 seconds. Last 10 seconds. Let's try to see. A player hits 8 goals out of 60 balls. Find the probability the player did not hit. See, out of 60, if he is hitting 8 goals, so how many times is not hitting the goal? Okay, so did not hit the goal. I'm sorry. did not hit the goal is 60 minus 8, which is 52. 60 minus 8, which is 52. Find the probability the player did not hit the goal, right? So from there we'll get 52 by 60. The total number of goals is 60, 52 by 60. So I think we can cancel with maybe 4 or 8. With 8 I think we cannot cancel. With 4 we can cancel, right? For 15s, I'm sorry, 4 15s and 4 1s, and this is 4 3s, 13 by 15. Do we have that option? Yes. So 13 by 15 is the correct answer. Okay, if it is asked the probability of hitting the goals, that becomes 8 by 60, which is the 4 2s and 4 50s. 2 by 15 is hitting the goal. This is for not hitting the goal. For not hitting the goal. So that is how we can find the probabilities of both the events. Okay. The next question. 3 unbiased coins are tossed together. The probability of getting at least 2 heads. At least 2 heads. Okay, you need to understand that. What do you mean by at least 2 heads? That is very important. So please try to understand that and start the question. So last 20 seconds, please do it fast. Right, the time is done. Last 5 seconds. Let's try to stop with that. Okay, let us see the answer. 3 unbiased. What do you mean unbiased? Unbiased means no change. It's a general coin. Okay. Unbiased coins are tossed together, 3 coins, and let's try to see what are all the possibilities when we have 3 coins. So we may get tail, 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 that is one possibility. Tail, tail, head, that is the second possibility. Tail, head, tail, and tail, head, head. Okay, the first 4 possibilities. The next head, tail, tail, head, tail, head, 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 tail, and the next one head, head, and head. Right, so these are the total 8 possibilities. The probability of getting at least 2 heads, at least means either we can get 2 heads or more than 2 heads. Okay, so 2 heads cases, no, only 1 head. 2 heads, yes, we have here. There are 0 heads, 1 head, no. 2 heads we have this case, 2 heads again, and one more, 3 heads will also come into this. Right, so 1, 2, 3, 4, so the total out of 8 events, we have 4 events. So 4 by 8, 4 by 8 is 1 by 2. 4 by 8 is 1 by 2. The probability of getting at least 2 heads is 1 by 2. That is the option 2. That is the option 2, right? So let's try to move forward for the next question. In a cricket match, a batsman hits a boundary 4 times out of 32 balls. In 32 balls, he is hitting 4 times. Okay. In a given ball, what is the probability that he does not hit the ball in the boundary? In a given ball, what is the probability that he does not hit the ball to the boundary? So please quickly do that. Last 20 seconds. Last 10 seconds. So quickly do it fast. Last 5. So let's try to see out of 32 if he is hitting 4 times. Out of 32 if he is hitting 4 times. So how many balls are there without hitting the target, hitting the boundary? 32 minus 4, 32 minus 4, 28 times, 28 balls is not hitting the boundary. So what is the probability? So 28 by 32, 28 by that I think we can cancel with 7, 7 4, sorry, 4 with 4, 4 sevens and 4 eights. 4 sevens are 28 and 4 eights are 32. So 7 by 8, that is the option A is the correct answer, right? So let's try to move forward to the next question. In a simultaneous throw of a pair of die, pair means 2, right? The probability of getting a sum more than 7, the probability of getting sum more than 7, a very beautiful question. So please try to do it fast. Last 30 seconds. Right, so that's all. We will try to solve this question. In a simultaneous throw of a pair of dice, the probability of getting a sum more than 7. Right, we know the total case of 36 cases. Once again, let's try to write all 36 cases. Right, so 1 1 1 2 1 3 1 4 1 5 1 6 2 1 2 2 2 3 2 4 2 5 2 6 3 1 3 2 3 3 3 4 3 5 3 6 3 3 6 4 1 4 2 4 3 4 4 4 5 and 4 6 5 1 5 2 5 3 5 4 5 5 5 6 and 6 1 6 2 6 3 6 4 6 5 and 6 6. Now the question is, the sum of these two numbers should be more than 7, not even equal to 7, more than 7. Now what we'll do, instead of finding all the numbers with greater than 7, let's try to delete where we get sum less than 7. Okay, 1 plus 1 is 2, 2 plus 1 is 3, 3 plus 1 4, 5, 6, 6 plus 1 7, not even 7, we need more than 7. Eliminate all this. 2 1 is eliminated, 2 2 is eliminated, 2 3 is eliminated, 2 4 6, 2 plus 5 7. All these numbers are eliminated, right? 2 plus 6 is 8, that can be included. 3 plus 1 is 4, 3 plus 2 is 5, 3 plus 3 is 6, 3 plus 4 is 7. This is also not correct. From 3 plus 5 it is 8 again. Okay, so 4 plus 1 5, 4 plus 2 6, 4 plus 3 is 7. No, from 4 plus 4 is 8. 5 plus 1, 5 plus 2, these are not correct, these are not counted, and even 6 comma 1 is not counted. So now tell me the probability of getting a sum more than 7. More than 7, let's try to add all this. 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15. So total case of 15 favorable by the total 36, 15 by 36. So do we have any option with that? I think we can cancel with 3 5s and 3 12. So 5 by 12, right? So 5 by 12 we have that option A. That is how you need to eliminate the numbers which are not more than 7. Even the 7 should not be included. Okay, so let's try to move forward to the next one. 3 unbiased coins are tossed together. The probability of getting at least 2 heads. At least means 2 or more than the probability of getting at least means minimum 2 heads or more than 2 heads. Okay, I think you can do that. We already solved the same type of question, right? So write all the possibilities and try to solve from there. What is the next question? If 2 coins are tossed simultaneously, the probability of getting at least 1 tail. 2 coins, that means the first coin and second coin. So now tell me how many possibilities are there? Tail, 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 head, head, tail, and head, head. When 2 coins are tossed, we have 4 possibilities. The probability of getting at least 1 tail. 2 tails is correct, 1 tail is correct, 1 tail is correct, no tail is not correct. So we have total 3 favorable out of the total 4 cases. So that answer will be 3 by 4. The answer will be 3 by 4, right? So let's try to move forward for the next question. An unbiased dice, again, unbiased dice is thrown. What is the probability of getting an even number or a multiple of 3? Okay, An unbiased dice, only one dice, okay, 1, 2, 3, 4, and 5, 6. These are the possible outcomes. What is the probability of getting an even number? So even number, even number, even number, or a multiple of 3. So even a number 3 should be included. So we have total 4 favorable cases, okay. So 4 favorable out of the total 6, 4 by 6, which is 2 by 3, 4 by 6, which is 2 by 3, that is the option B. That is the option B, right? These are all very simple questions, and we have a lot of more advanced applications on probabilities which we are going to cover in the next coming classes, right? Thank you so much, students. Stay tuned to get the next lecture. Thank you.
Yeah. Hello everyone. So now again we'll be continuing with what? Free fall. Okay, so my name is Shashan Reddy. I'm a graduate from IIT NEET. Let's go into the class. Let us also first of all revise whatever we have learned in the previous class. Right? So we learned about free fall. What is free fall? We looked into the definition of free fall also. We have watched 2 videos on free fall also. Right? Interesting ones. Yes. So what is free fall? Free fall is the motion in which gravitational force by the earth is the only force acting. When I say only force acting, there is no wind, there is no friction due to air, nothing. No other force is acting, only gravitational force by the earth is acting. Simple example, if I throw a body up, while going up there is only gravitational force acting, and while coming down also there is only gravitational force acting. Okay. Okay. The thing is, what do? We neglect air friction. We call it as air resistance. We neglect them. I know that in practical cases, when you throw a ball up, because of air there will be friction, there will be drag, air resistance, but we neglect it. Because when compared to gravitational force, it will be small. That is the reason we neglect it. But again, when you go for exact calculations, you have to consider that. But for now, we neglect air resistance. Only one force is acting, which force? Gravitational force by the earth. And in that case, what is the acceleration? In that particular case, acceleration will be equal to g in which direction? In the downward direction. In the downward direction. Okay, good. And I think in the last class, we have learnt about downward motion. Upward motion we'll discuss now. But we discussed about downward motion, yes or no? In downward motion, very quick, what are the points? If you drop a ball, okay, an object is dropped. When you drop an object, what happens at the top? Its speed will be 0. Right, here the speed is 0 and it comes down. Its speed will keep on increasing, so speed increases. So acceleration is equal to plus g, positive. And what is g? G is equal to 9.8 meter per second square. Is it constant? Yes, it is constant. So it is uniformly accelerated motion. So we can go for the equations, kinematic equations, or the equations of motion. First, v is equal to u plus at, u is equal to 0. The equation becomes v is equal to gt. Then s is equal to half gt square. Then v square is equal to 2gs. But again we can say that s is equal to capital H minus small h. What is capital H? The total height. What is small h? The height at the point that we are considering. Yes or no? So if the object has come from point A to B, from A to B, its displacement will be this. And what is that displacement? Equal to capital H minus small h. So these are the points that we have discussed in the last class. We have even solved a problem on that. Right? Now what we will do is we will be going into upward motion. That is, if we throw a body upwards, what is going to happen? Got it? Let's understand the upward motion then. Upward motion. Now first of all, imagine this. If you throw a body up, it's going up. Does its speed increase or decrease? The first point. As the body is going up, does its speed increase or decrease? Yeah, everyone. Does the speed increase or decrease? This is the ground, by the way, not a plane mirror, it is ground. The body is going up. What happens? As the body starts going up, its speed decreases. Speed decreases with height as it goes up. And if speed decreases, we say that it is retardation. Right, so acceleration will be negative. There is another way of telling this. See, as the body is going up, its velocity will be upwards. But we know that the acceleration due to gravity is downwards. So the velocity and acceleration are in opposite directions. That means again retardation. So we can say A is equal to minus G and is constant. So it is uniformly accelerated motion. So free fall is a uniformly accelerated motion because acceleration is constant. Understood? Good. So A is equal to minus G. Now, what other conditions are there? See here, at the topmost point, what happens if you throw a ball up? As it goes up, what happens? Its speed decreases continuously. At the topmost point, it stops for a second. Like not even for a second, for an instant it stops. Right? For example, imagine you are throwing a ball up with a speed of 10 meter per second. Here, let's say u is equal to 10 meter per second. Now, as it goes up, the speed keeps on decreasing. 10 becomes 9, 9 becomes 8, 8 becomes 7, 6, 5, 4, 3, 2, 1. After 1, 0.5, 0.25, then ultimately it should become 0. Right, so at the topmost point, speed is equal to 0. Very important point. V is equal to 0 at the topmost point. Clear? Good. So we have A is equal to minus G, we have V is equal to 0, we have two conditions. Right, and I'll take any other point. Let's say I'll take this point. Right, here A is the initial point. Let's say at B we have to find out the speed. We have to find out the speed at what? At B. So here just let's look at the displacement. What is this? A to B, it is going up. That is the displacement. But again it is what? It is the height of B. So I can say that S is equal to H. Right? This is the height of B. It is again going from A to B. So displacement is equal to height. You can also say that point S is equal to H. S is equal to H. Obviously at A we are beginning, so T is equal to 0. Okay. And time taken to reach the highest point is called time of ascent. Time of ascent, let me call it as capital T in the subscript A. What is that? It is time taken to reach highest point. Time taken to reach the topmost point. Clear? So this is some basic information for what? For upward motion. Now using this information, let's try to get the kinematic equations for them, or the equations of motion. So let's go into that. So first is, we got the conditions as A is equal to minus G, right? So if I need velocity with speed at any point of time. Here imagine you are throwing a ball up with a speed u, initial speed. It goes up, okay, it goes up. And at some point, you need what? You need the speed. Just a minute. Right, at some point, you need speed v. Right, so you can say at time t also, time t, right, and height h, anything. So if I use the equation v is equal to u plus at, u is there. But a is what? Minus g. So v becomes u minus gt. This becomes equation 1. A is equal to minus g. So at time t, after some time, let's say after 1 second, after 2 seconds, after 3 seconds, So at some time t, the ball is here. So at that instant, at that time, if I need the speed, I will use this equation. Then again, you can use S is equal to ut plus half at square. But we already got that S is equal to h. So h is equal to ut. U is not 0, ut. But a is minus g, so plus into minus becomes minus. It becomes minus half gt square. That becomes equation 2. Now what does this give? This gives us the height at time t. So after some time t, where is the ball? At what height is the ball? At height h. And that height h is this. So you'll get that using this equation. Then we have another equation, v square is equal to u square plus 2as. Here also, v square speed after some height, u is not 0, a is minus g plus into minus minus, minus 2g, s is h. So this becomes equation 3. And what does this give us? This gives us speed at the height h. In first two equations we have time. In the third equation we have the relation between speed and height h. So after, let's say, after the ball goes to a height of 2 meters, what is the height? What is the speed? You'll get it using this equation. So equations 1, 2 and 3. So should we remember it? Not required. But you have to remember the conditions so that using the conditions you can get those 3 equations. Got it? So let's go into the problem. Let's go into a simple problem and we'll understand. But all the points that we discussed are given here. You can go through them. See. Okay. So now let's go into the problem. A very simple problem. Basic one. Let's go into it. So what is the problem here, or what is the question here? Just a minute. Just a minute. So an object is thrown vertically upwards. So vertically up, it's going straight up and rises to a height of 10 meters. So it goes to a maximum height of 10 meters. Calculate the velocity with which the body was thrown upwards. Okay, we'll go into A. B and C will again come back. So what is given here? What is given is, let's say this is ground. It is thrown with some speed, right? So let's say this is U, and here this is the topmost point. And at the topmost point, what is the speed? It goes up, 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 up. Speed decreases, 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 and at the topmost point, the speed becomes 0. What they have given us is this height. It reaches a height of 10 meters. So the maximum height is given as what? 10 meters. That is what is given. Right? So given information, you can say h is equal to 10 meters. Okay? And acceleration is not given. We'll take, or I'll just write it down. Calculate and all, you'll do it. Take g is equal to 10 meter per second square. So that our calculation becomes easier. Okay. H is given. And A is equal to minus g. So now if I do this, I'll go with case A. At the topmost point, V is equal to 0. Speed is equal to 0. That is final, right? And what about displacement from initial to final? See this, what is displacement? From ground to the topmost point, displacement is nothing but height h. So S is equal to capital H, that is equal to 10 meters. So V is equal to 0, we have one quantity, we have final velocity, we have displacement, and we know that for upward motion, A is equal to minus G, which means minus 10 meter per second square. So we have how many quantities? We have 3. And remember this, in the equations of motion, if you have 3 quantities, you will automatically get the other 2 using proper equation. So we have V, we have S, we have A, and our goal is to find out the velocity with which the body was thrown upward. So the velocity with which you are throwing it up. Right, so at the ground, what is the speed or what is the initial velocity? We have to find out U. So which equation do I use? I can use this equation v square is equal to u square plus 2as. Why? Because here, look at this. Do we have v? Yes, we have v. Do we have s? Yes, we have s. Do we have a? Yes, we have a. So u is the only quantity that we don't have. So we will get it. Yes. So v square, where is v? 0. So it is 0 equal to u square plus 2 into a is minus 10. S is also 10. S is also 10. So 0 is equal to plus into minus. What is that going to be? Plus into minus. What is that? Minus. Right. Then you have 2 into 10 into 10. Right. That is u square minus 200. U square minus 200. So that becomes what? Minus 200 goes to that side. It becomes plus. So u square is equal to 200, or u is equal to under root of 200. Under root of 200. Just a minute. I think if we take g as 9.8, 9.8 into 2, 98, and that I think becomes much more easier. Okay. Okay, let's do it this way. But I'll also show you by taking g is equal to 9.8. So here u is equal to under root of 200. Now what can you write under root of 200 as? It is 2 into 100. Under root 100 is 10. So u is equal to 10 root 2 meter per second. There you have it. You got the answer. Right, and we have taken g as 10 meter per second square, and then in that case you get u is equal to 10 root. Now see what happens if I take g is equal to 9.8. In fact, that will be easier. Let me show that to you. Okay, A. The same conditions, v is equal to 0, s is equal to 10 meters, a is equal to minus g minus 9.8 meter per second square. That's it. And we have to find out u. We'll use this equation. V square is equal to u square plus 2as. Right, v is 0. We have to find out u plus 2 into a minus 9.8 into s. S is 10. Then it becomes what? See here. Plus into minus minus. 0 is equal to u square minus. I'll not multiply much. 9.8 into 10 becomes 98. So minus 2 into 9.8. Do not solve it. Leave it there itself. Sorry. 9.8 into 10 is 98. So I'll just say 98. So that minus term goes to the other side. U square becomes equal to 2 into 98. Now here see, when I take u, it is the under root of 2 into 98. What is 98? It is 2 into 49. 49 into 2. How much is that? 49 into 2 is what? 98. And what is the beauty here? Under root of 2 into 2 is 2. Under root of 49 is 7. It is under, so it will be what? The answer will be 2 into 7, that is 14 meter per second. So if we take the value of g as 9.8 meter per second square, we are getting the simpler answer. So we'll proceed with 9.8 itself. If we have taken it as 10, we are getting 10 root 2. So you might be asking, sir, 10 root 2 and 14, they are very far. No, they are not very far. 10 root 2 will be 14.12. 14.12 and this is 14. Not much difference. Right? But you understood, right? So we got what? We got the initial speed. We got what? Initial velocity or initial speed. Clear? So everything, see, if you draw the diagram, you'll understand what is happening. So even if they haven't asked to draw a diagram, please draw it. For your sake, you can imagine what is happening and you can understand things better. Good? Okay. The second is what? The time taken by the object to reach the highest point. Same diagram. We have to calculate the time taken to reach the highest point from here to here. That's it. Now that we have, again I can say B. I'll take at the topmost point. I'm taking that point. Yes or no? Topmost point. What do we have now? We know that we got u is equal to 14 meter per second. But the topmost point v is equal to 0. And we know that a is equal to minus g, which is minus 9.8 meter per second square. And we have to find the time. How do we find the time? It's very simple. We know that a is equal to v minus u by t. So if you interchange time and a, time becomes equal to v minus u by a. Just use this. So t is equal to v minus u by a. V is what? 0. Minus u is how much? 14. By a is minus 9.8. Minus 9.8. 0 minus 14 is minus 14. Upon minus 9.8. Now you have to do the calculation, right? See here, minus minus cancels. Okay. Then you have 14 divided by my 9.8. What is that going to be? Multiply into 10 on both the sides, numerator and denominator. It becomes 140 divided by 98. And then you can divide it with 14 itself if you need. Or if you want to do a simpler calculation, divide it with 7. 7 20s are 7 2s are 14. And here it becomes 7 1s are 7, 28, 7 4s are. Right? Yeah. Then again you can divide with 2. 2 10s are, 2 7s are. That becomes equal to what? That becomes equal to 10 by 7. SI unit, so 10 by 7 seconds. So the time of ascent, time taken to reach the topmost point is 10 by 7 seconds. You can convert that into decimals, you'll get it as 1.43 something, 1.43. 1.43 seconds. There you have it. Simple, right? See, everything depends on what? The equation. So before the equation, if you understand the case, get the given information, you will get the answer. You will get the answer. And as I told you, if you have 3 quantities, see here, 1, 2, 3. If I have 3 of them, I'll get the others. I'll get the others. Okay? Good. So this is also done. Good. So we found out initial speed, we found out time taken to reach the topmost point. And what is the third case? The third case is the speed when the body is at half the maximum height. Understand this case. Now again we'll draw the case. Here is ground. This is the topmost point. Total height as we know is 10 meters. But half will mean how much? The height is going to be 5 meters. So we have to find the speed here. And we got u as 14 meter per second. So throwing a ball up with 14 meter per second, it travels a distance of 5 meters and we have to find the speed. So what is the information that we have in this case? Case C. Initial speed is 14 meter per second. The displacement, it is going up, it is 5 meters. Yes or no? See, from here to here, how much is the displacement? Straight line length is 5 meters. And when it goes up, speed decreases, so acceleration is negative. And as we know, acceleration is downward, so retardation, negative. So A is equal to minus G, we will take it as minus 9.8 meter per second square. So you have U, you have S, you have A. What we have to do is, we have to find out what? Speed, yes or no, if I am correct, the speed. So again, how many quantities do we have here? Count them. 1, 2, 3. If you have 3, you will get the 4th one and 5th one. What is missing here? V is missing and time is missing. You will get these 2 using proper equation. You have to use the proper equation. That's it. So which equation am I going to use? Or which equation should we use? We have to find out V. We'll use the equation V square is equal to U square plus 2AS. So V square is equal to, what is U? 14. So 14 square. Plus 2AS. So plus 2 into A is minus 9.8 and S is 5. Then what is 14 square? 14 into 14. How much is that? 196. Yes or no? Let's verify. 14, 4, 4, 16, 1 carry. 4, 2, 8. 8 plus 1, 9 and 196. Correct. Then 2 into 5 is 10. Right, 2 into 5 is 10. 10 into 9.8, 98. Then you have 2 into minus, becomes minus 98. Now what is 196 minus 98? 98 itself. 98 itself. You can do that. Because 98 into 2 is 196. So V square is equal to 98. We need V. It is under root 98. And as we discussed, what is 98? 49 into 2. And what is under root 49? 7. So it is 7 root 2 meter per second. There you have it. That is the answer. Right, see, always the steps are simple. Given information, formula, substitute, solve. So, it is more important to understand the case and find out the given information. If you have it, you can solve it. That is the reason why I draw the diagram. It helps us in understanding the case better. Got it? So, that is an example of upward motion in free fall. There are a few questions, so let's go into some more questions. Okay, now these are more logical or theoretical questions. And please do practice the same question again. Whatever I have explained, please do practice the same question. So that verify whether you have understood or not. If you haven't, then again go through the notes. See where you have gone wrong. And again continue. Okay, so we have a simple question here. The speed of an object thrown up, dash, and that of an object dropped from a height, dash. Fill in the blank and you have a few options. What is that going to be? A, B, C and D. Everyone. The speed of an object thrown up. What happens to it? Decreases. Yes or no? Decreases. And the speed of an object dropped from a height increases. So the answer is going to be what? The answer is going to be decreases and then increases. Option B. Option B. Good. Next. An object thrown up will be in acceleration or retardation. What is that? An object thrown up. If you throw an object up, what happens to its speed? Just now we discussed. An object thrown up, its speed decreases. And if its speed decreases, what is that? It is retardation. It is retardation. Clear? Good. Now again, another thing. For an object thrown upwards, which is the correct acceleration? A is equal to G or A is equal to minus G? Now run. Which one? For an object thrown upwards, A is equal to G or A is equal to minus G? The answer will be? The correct answer is A is equal to minus G, because for an object thrown upwards, you told me here, it is retardation. Retardation will mean negative acceleration. That is the reason why the answer is minus G. Got it? Good. Another question. Very simple one. Does acceleration due to gravity depend on the mass of the object? Very simple, but a classic question here. Yes or no? Does acceleration due to gravity depend on the mass of the object? Yeah? The answer is no. It does not. For every object, the acceleration due to gravity on Earth is 9.8 meter per second square. That's it. And not because, see, what is the formula for G? Capital G, mass of Earth upon radius of Earth square. Do you have mass of object in this? We do not have mass of object in this, so that means G does not depend on mass of object. Right? Good. So the answer is what? No. Does it depend on mass of object? No. Good. So you have one more question here, but this I'll leave it to you. We don't have much time. Okay. So these two, let me leave it to you. Okay. Okay. So please do practice them. Okay. So thank you. Thanks a lot.